Here you can see the CircuitPython NRF5280 module that we frequently and consistently utilize, and there is an additional and supplementary expansion board here. On the right side of this expansion board, you can connect the I2C to the SCL and SDA pins, as you can clearly and distinctly observe. And here is the OLED display, which is located and functions seamlessly and efficiently with the SSD1306 driver, a component that is specifically designed to fit perfectly with the pin map indicated on the OLED pin port. So you just need to carefully connect it like this, step by step, ensuring each connection is secure and stable, and then please gently insert the module securely like this, ensuring everything is properly aligned before proceeding to the next step. This is the code from last time, as demonstrated in the previous session, but I will erase it and start fresh to avoid any issues and ensure a clean start. After importing mode, there is from Akai import I2C slightly. After doing this, you will use the import library, and as I have already mentioned, it operates with the SSD1306 driver, and there is an SSD1306 library available. And then, basically, in I2C mode, it's essentially the SCK, the clock pin, which is very crucial and significant. Baud. MOSI. As you know, this is now the data pin. Then display radar. Volt, SSD1306, SSID, I2C. So, we set the resolution. The resolution we use is 64 out of a maximum of 128, and since we are using the I2C interface, control is based on the address, allowing us to control from 0 to 30. The usage is simple. First, you can set the display to fill 0, which allows you to set it from 0 to 2. If you set it to 0, it will completely darken the screen, essentially clearing it. You can think of it as a clear function. If you save this, the screen won't change. When I modify the settings and change it to this particular state, it undergoes a transformation and completely turns white, just like this. This change is quite noticeable, and you can think of it as a process of completely clearing or resetting. This transformation is significant and can be seen as a complete reset or clearing of the previous state. Alright, let's move forward with the next step in our demonstration. At this point, I will attempt to draw a single pixel E on the display screen. To achieve this, we utilize the command displayPixel X, Y1. This specific command is designed to place a pixel at the given coordinates on the screen. Now, while I am not entirely certain if the pixel will be displayed perfectly due to the flexibility of the display settings, you should be able to notice a small dot appearing at the designated location, correct? In this current mode, I will proceed to draw a horizontal line across the screen. The command for this is display hline 5020 once. By executing this command, a horizontal line is effectively drawn from the starting point to the end point. This method allows you to create lines in a straightforward manner, and similarly, you can also construct rectangles using a different command. For instance, the command display left 5, 15, 20. 11 is used to draw a rectangle. When this command is executed and saved, a rectangle will appear on the display. Now, moving on to the next shape, let's attempt to draw a circle. The command for this is display circle 50, 15, 10. By adjusting the parameters of this command, a circle is drawn on the screen, appearing as a perfect round shape. This demonstrates the versatility of the display commands in creating various shapes and lines. Additionally, these commands offer a wide range of possibilities for creating intricate designs and patterns on the display, allowing for a high degree of customization and creativity in how you choose to present visual information. You can also input text characters. If you look here in the root, you can see the binary file. This is the font file. To input text using this system, start by typing your desired text into the input field. Once entered, the system processes it for display. For example, the text hello device monet 5401.name is saved to match the file name, ensuring it shows hello device mart. This process ensures the displayed text is accurate and user-friendly, providing a seamless experience. The system's ability to match input text with the correct file name enhances its functionality. By following these steps, users can be confident their input will be accurately reflected in the display output. In this way, you can draw shapes output text on the OLED using I2C. In this session, I controlled an OLED display that operates with the SSD1306 driver using I2C and CircuitPython. I will return with more additional and valuable content next time.